Hi, I'm Akshay and I'll be walking you through our outlier analysis function. So in this slide you can see the definition of outliers. So what are outliers? And you can also see why is outlier analysis important. By definition, outliers are points that are distant from remaining observations. As a result, they can affect the mean and median, which in turn affects the error, the absolute error and the mean error, and hence any analysis performed on the dataset. And almost every data set contains outliers. So analyzing the outliers is really important, and doing it separately or individually for each data set is really time consuming, hence the need for this function. So this box plot in this slide tells you how to figure out the outliers. How do we figure out the lower bound and how do we figure out an upper bound? So there has to be a threshold above which or beyond which we'll classify an observation as an outlier. So the mathematical formula for that is, for the lower bound is Q1 minus 1.5 times the interquartile range, and the interquartile range is Q3 minus Q1. And for the upper bound, the formula is Q3 plus 1.5 times IQR. And in this box plot, everything has been labeled properly. So everything lying above the upper extreme or anything lying below the lower extreme will be classified as an outlier, and that is the goal of our function. So now I'll be moving on to our function in R, and I'll walk you through my code. So outlier detection is the name of my function, and within my function I have another function which is called outlier single. So outlier single helps me figure out outliers within a single column, and then I'll be applying this function on the entire data set on all the columns. Hence I've made a function inside a function. So the first statement checks if my column is numeric. And if it is numeric, then it within in Q3 and Q1 it stores the third quartile and the first quartile. And I've also performed this function also does it for log. Log is supposed to reduce the number of outliers. So everything that I do for all the columns is repeated for all the log columns as well, as you can see here. And now moving on, I figure out the threshold, the upper threshold, which is labeled as the upper limit, using the same formula which I showed you in the presentation. And similarly, I found out the lower limit, and I've done the same two things for the log as well. And now I get rid of all the NA observations since we don't need them in the outlier analysis. And num upper here stores the sum of the number of observations which are beyond the upper limit, and similarly num lower stores the sum of the number of observations which are lower the lower limit. So if we add num upper and num lower, we'll get the total number of outliers in our column, not in the data set, since this function is only for individual columns, and we'll apply this to the whole data set to get the outliers of the entire data set. And similarly, I've used num upper log and num lower log to get the number of outliers beyond the upper limit and below the lower limit for after we apply log. And finally, we have to combine a result and make a table. So I use a vector and combine all four of them and return it. Else, in this block of code, this is for factor or character columns. Basically, if it's not numeric, then you just want to basically have a dash and no outliers. And finally, I apply sapply, which gives me a vector of all the which gives me a vector when I apply this function outlier single on my entire data set. And finally, I take a transpose and return it. So just to demonstrate my function, I've applied this on the Framingham data set. I'll apply it again. Outlier detection, it only takes a single parameter, which is the data frame. And just to show the output clearly, I'll move back to the presentation. And over here, you can see the output. So on the left hand side, in the first column, it lists all the columns of a data frame. The first column is upper count, which represents the number of outliers which cross the upper boundary, which is the upper count. The second column is lower count, which tells us the number of outliers which were below the lower count, which was Q1 minus 1.5 times upper quartile range. And similarly for the last two columns, is the same thing only when after log has been applied. Thank you. If you have any further questions regarding our code, you can always refer to the link, and we have the GitHub link and you can follow the code over there. And if you have any further questions, you can post those questions in the comments, and I'll be happy to answer them.